Continuing on from the last video on conservation of momentum, I want to focus on introducing some events in which momentum is conserved. In particular, understanding collisions using the principle of conservation of momentum, and then applying that to an example question I have. Here are the three main events that I'll be focusing on where momentum is conserved. We have collisions or bounces, so where an object hits another object and that object flies off. Sometimes the original object may also rebound and bounce backwards. Coupling, where an object hits another object and they move off stuck together. And finally, explosions, where objects that were initially together move apart due to a sudden release of energy. I'm only going to be focusing on an example for collisions in this video, represented with this scenario. A large object collides with a smaller object that's not moving. Then after the collision, the smaller object is moving whilst the bigger object is stationary. The larger object has transferred all of its kinetic energy to the smaller object. Now, we're told that a large yellow ball of mass 20 grams collides with a smaller pink ball that is at rest and has a mass of 5 grams. After the collision, the pink ball moves with a velocity of 25 meters per second to the right, and the yellow ball remains stationary. What is the initial velocity of the yellow ball before the collision? The first thing I do is just write out the variables we're given. I'm going to label the large yellow ball 1 and the smaller pink ball 2. The yellow ball has a mass of 20 grams, which converts to 0.02 kilograms. Similarly, the pink ball has a mass of 0.005 kilograms. U1 represents the initial velocity of the yellow ball, which we're looking for. The initial velocity of the pink ball is 0 as it's at rest. After the event, in this case the collision, the final velocity of the yellow ball v1 is 0, and the final velocity of the pink ball is 25 meters per second. In order to answer this question, the big thing we need to remember is that the total momentum before the collision is equal to the total momentum after the collision. Recall that this was the principle of conservation of momentum. We know that the momentum, p, is equal to the mass multiplied by velocity, and using the principle of conservation of momentum, we can say that the mass of the yellow ball multiplied by its initial velocity, add the mass of the pink ball multiplied by its initial velocity, is equal to the mass of the yellow ball multiplied by its final velocity after the collision, add the mass of the pink ball multiplied by its final velocity. That gives us 0.02 multiplied by u1, which is what we're looking for, add 0.005 times 0, is equal to 0.02 times 0, add 0.005 times 25. That tells us that 0.02 u1 is equal to 0.125, as this reduces to 0, and this also reduces to 0. Rearranging to make u1 the subject, so dividing 0.125 by 0.02, gives us 6.25 meters per second as the initial velocity of the yellow ball before the collision. To quickly check that, you may have noticed that the large yellow ball has a mass of exactly 4 times the mass of the smaller pink ball. Since p equals mv, to make sure momentum is conserved after the collision, the pink ball is going to have to travel at 4 times the speed to make up for its smaller mass. So if we divide 25 by 4, we also get the speed of the yellow ball, 6.25 meters per second. I hope that example was helpful. Remember to be wary of your directions. If one of the balls was moving in the opposite direction, so it bounced off during the collision, you'd have to make sure the signs of your velocities made sense. In the next video, I'll be going over conservation of momentum with an example of coupling.